Okay. Okay. Welcome everyone to Cloud Data Driven Online User Group meeting.
Hello.
Yep. As you already know, I am Jean-Joseph, currently located in New Jersey, originally from Haiti, and I'm your host for today. What are the rules? You guys are free to comment, but do it with respect. There must be no offensive comments. I have your video turned off, but you guys do have access to unmute yourself. If you have any questions, feel free to raise your hand and the speaker or myself will address it accordingly. Let us connect it. Follow us on social media at Cloud Data Driven. Also, don't forget to visit our data community website like Data Saturdays and SQL Saturdays. I would highly suggest you guys to go and register for Feature Data Driven Summit event, which will be in September 29. It will be a full day of different contents. Please, guys, save your spot. Okay, our agenda for today is migrating a data capture solutions with Event Hub and Stream Analytic. And we have Mark as our speaker. Mark, it is an honor to have you here, and thank you so much for your presentations. Mark is a Microsoft Data Platform consultant. He's an MVP, and he's a speaker as well. For our feature presentations, we have financial data modeling with Power BI, which is Bob, will deliver these sessions for us. We also have advanced data type JSON, which is Dami. I would highly suggest you guys to save your spot. And then if you guys want to present the sessions, feel free to email me at jean.joseph@bigdatadriven.org. One more time, thank you all for attending our webinar. And Mark, the floor is all yours. You are free to introduce yourself and start with the presentations. And it is an honor to have you here, Mike. Mark, please feel free to share your screen. Thanks.
Perfect. Thank you, Jean. Thank you very much. Hopefully everybody can hear me. Might just confirm there, Jean, you can hear me, yeah? Yeah, I'm going to take that as good. Okay, I'm seeing a thumbs up.
Yes, I can.
I'm seeing a thumbs up from Ed Pearson. That's awesome. Hello, Ed. Okay, so let's practice our thumbs up things, all right? So who here's from, okay, the United States? Let's start it nice and easy. Come on, let's practice a thumbs up. It's up there on your team somewhere, you know. I'm seeing a few, Okay, who's here? Okay, New Yorkers. How many New York State people here? You know, I see any more thumbs? Oh, there's another thumbs popping up in there. You'd be obviously. I'm from Ireland. I'm Irish. You'd be hard pressed to find an Irish person who doesn't like America. I've spent some time in New York and around Chicago and San Francisco and stuff like that. So it's great to be talking to you. Give you an idea of where I'm from. Here's Ireland. I assume you can all see my screen. So give me a thumbs up there again, someone, if you can see my screen. As I zoom in, I'm from South Ireland, so I'm down around this part in a place called Cork. If I zoom into Cork, I'm actually in a village outside of Cork called Blarney. And if we zoom into Blarney, Blarney is noted for a very famous castle called the Blarney Castle. And there it is. So it's this big old Norman castle that we have in Blarney. And if you see that there, that line there, that's actually a queue of people waiting up to kiss the Blarney Stone. So it's a thing where they hang you over the side. Not quite, but close to the side. And you kiss the stone and you can get the gift of the gab or the gift of elegance. So that's where I'm coming from, not literally the castle, but you know, this is where I live, and I actually technically live up here. So this is my house. This is where I'm coming from, live right now from this part. So that's me. I'm Irish, I'm from Blarney. Let's pop up a quick little bit about me here, working with data since 1999, MVP data platform. I do a lot of BI stuff, basically. We work with OLAP services back in 2000 and analysis service since then, and more recently a lot of Power Platform, Power. I need a very couple of users in there as well and stuff like that. Okay, that's enough about me. Let's talk about what I want to talk about first of all. And any demo I like to do, I like to have a business case. You know, kind of like this is what's going on. So actually, the history of this one is kind of fairly old now. It goes back to 2012 when a company approached me and they basically wanted to develop a system that could capture your full MAC address. Okay, so whenever you walk near a router, okay, your actual MAC address is captured. Okay, even if you don't use the Wi-Fi, it's just captured. Okay, it's aware that you're there basically. All right. So if you can capture that information, you actually can get a lot of insight out of that. If you have something like in a shop, you can basically tell, well, this MAC address is visible and how long it was visible for. So you can tell things like how many people pass your shop, how long do they stay, how frequently do they come back. You could even, and they also wanted to react to live data in the system. Okay, so they wanted that. They wanted to develop something to do this. Okay, if I was to look at that from a few angles, both from the need to potentially create large volumes of data, because if you put on a lot of shops, it could generate a lot of data, but also they wanted to react to incoming data. We would now call that streaming data, okay? Just continuously arriving data that you want to work with. So what did we do back in 2012, 2013? Well, basically, you kind of had to develop something. You got a Wi-Fi route, you got a router, develop a web service that would receive the router signals, put that onto a file share, then had a lot of integration services packages that were putting that into a SQL database, and then we put some reporting services in front of it. Okay, and we pull that put into a VM, and we got FTP, IIS, operating systems, all that sort of stuff. Basically, a lot of moving parts to kind of build that solution. So I thought it would be interesting to revisit that and kind of go, well, how would I potentially approach that solution now? Okay, and that's what the rest of the session is about, basically. How would I actually go about and meet this project now? Well, I'm going to do it via streaming data. Okay, so let's talk about streaming data. What do we mean by streaming? It's one of the V's of big data. All right, so you got the volume, veracity, velocity, sparsity, and value. Well, we're really specifically talking about the velocity side of things in here, because that's the key distinction feature about streaming data. It's always arriving. It's continuously coming in. The speed at which data is generated. It arrives continuously, and you want to perform analysis on it when it arrives, which is another key feature. It's not enough that it's arriving all the time, because data arriving all the time, but you don't need to process it until the end of the day. That's not really streaming. You can just batch process that at the end of the day. But data that's arriving in and you want to perform some analysis on it, then you're back into the whole streaming side of things, that continual analysis side. So the new way that this would work would be, I would still have my router sending data, but now I'm going to send that data to an event hub, to an Azure event hub. And that event hub is going to pass that to a stream analytics job. And a stream analytics job will put it into a SQL database, and then we probably put Power BI or something like that in front of it. So what I'm going to be talking about really are these two components in here. The event hub, which is the web service that receives messages and queues them, and the stream analytics job, which is a service that connects to the event hub, takes that data and performs my analysis. The SQL database and the Power BI, we're really not going to go near that much at all today. And of course, this is all now in Azure platform as a service approach to doing this work. Let's demo. Let's just get an initial look of what we actually are going to be working. So let me flick over. A couple of nuts and bolts. I obviously haven't got a router up and running here to actually do this, so I'm just simulating a router. So I've just got a bit of C# code in here, and we can see a stream of data coming out of it at the moment. Okay, and I'm just mimicking MAC addresses. Obviously, it's not a MAC address I'm putting in, it's just something that represents a MAC address. So that's my bit of C# code in the background running away. Okay. In terms of what I'm expecting to get, well, let's do a quick count in here. The last time I ran this count on this database, I had 263,000 rows of data in it. So let's run a count again now and see what we got. So now I got 725,000 rows of data in it. Okay. Data, if I go looking at it. Simple, straightforward table in here, just capturing it. You can see I've got a timestamp. I'm mimicking an access point. I'm mimicking a MAC address. And then I got a classification thing going on in here. I'm trying to work out whether a MAC address is a visitor or a passerby. So a little bit of basic analysis, and then a count of how frequently I've seen that in that window. So now let's run this count again, and it should have gone up. Now you can see now I'm up to 741,000. So that was about what, 30 seconds, a minute later. So clearly something's going into my database, right? All I've shown you so far is something's arrived into a database. If we go back to see what arrived, well, we've taken the stream of data. This is our stream of data. And here are the two things that are receiving it. Over here, I've got an event hub. Let's click on that event hub. I'm in an Azure plane here, obviously. And now I'm beginning to see a lot of activity going on in here. All right, so there's messages, there's requests coming in to my event hub. These are the volume of messages that are being received by my event hub. And here's my overall throughput. So stuff is coming into my event hub all the time. But where's it going? All right. And actually at the moment it's going nowhere. The event hub is simply holding it. That's what an event hub does. Gets a message, holds it. However, we can look at our second part, which is a stream analytics job. And the stream analytics job has got 4 key components, all right? This one is running at the moment, but if I look over here, I've got an input, function, query, and output. If I scroll down a little bit, no, they're actually regenerating at the moment. Let's just repage that. That's better. So you can see in here, I can see that this event hub is clearly doing a bit of work because these are messages it's receiving. So here, there's this blue line are my incoming events into an event hub. This is my output. This is what I have been pushing somewhere into my database. And over here, I can see a utilization. So I've got this event hub, sorry, this stream analytics job was running away at 20% when I was sending it nothing. And then I started sending data, and now it's sitting around about 25%. So not very taxed, just CPU, a little bit of CPU consumption going on there. Let's look at the building blocks around that. So it's got 3 critical components and kind of a 4th optional, all right? A stream analytics job has to have an input, okay? So it's got to get its data from somewhere, all right? So if I look in here, I can select one of the 3 types of input from an event hub, from an IoT hub, which is basically an event hub, and also I can put it straight from blob storage, all right? So my input is an event hub, and you can see in here how I have a couple of inputs set up. And one of them is something called console source, and it's a stream type, and it's an event hub. So that's basically reaching back to my event hub that was just receiving the messages. Again, the event hub, it just receives a message and holds it, waiting for something else to do. So this is the something else coming in, taking the data. Let's go out and look at the other parts. So that's an input. It has to put it somewhere, right? It's got to put it somewhere. So it's putting it into an Azure SQL database. So let's look at our outputs. All right. I can't add in any output at the moment. I'll show you how that in a little bit later. But in here at the moment, you can see that I've got one output set up. All right. And it's a SQL database. Okay. So an output. And then the bit in the middle. The bit in the middle is the query. If I look at this query, lots of SQL statements in here. This is the one that's relevant at the moment. And this is the only bit of code I had to develop to make this solution work. Everything else is just spin up services, but this is the only bit of code in here. And if you look over on the left, you can see again, I note my inputs, I note my outputs, and we see in the SQL statement how we reference them. Okay, so I'm selecting from something called console source. So that console source is not a table, it is an input, and the input is an event hub. Okay. It puts it somewhere, so it puts it into the sink, which is an output defined in there, and you can see how it's putting it into my stream analytics demo. Now that sink is a SQL database behind it, but it's actually it's not a table in the sense of stream analytics' view, it's just an output. And then the rest of the things that happen on here is just some basic analysis of analyzing the data. So basically it's just doing a grouping up by the access point and the MAC address, it's doing a quick count to see how many times it's seen it. If it sees it more than 5 times, it's considered as a visitor, otherwise passerby. And then there's this group by down here, and this thing, session window. And this session window is actually the bit that's really making it all work. It's basically saying I'll take from the event hub, put it into my SQL database, into my sink, but do some analysis over a time window. And we're going to talk a lot more about these time windows shortly. All right. So there's something called a session window. That's just in that, which is a period of time. It says over this period of time, do some analysis and then move on to the next period of time. So that's the basic kind of what we have. All right. And again, a last check to see how many rows have come in since, and we should be probably well past 800,000 rows now. And we are. Okay, so continuously streaming going on. Let's pop back to PowerPoint for a second. Excuse me. That's the basic building of what we built. But let's look at the heart of it, which is the window and functions. So window and functions. Analysis of streaming data involving the segmentation of data into temporal windows. It's very Star Trek sci-fi sounding thing. Basically, it's a way of grouping data, grouping events over time. We've got 5 of them. We've got them. Sliding window, session window, and a snapshot window. All of the rest of the images I'm about to show you come from Microsoft Docs, so you can pull them down there anytime you want. But they like to explain it via tweaks. Okay, so let's talk that through in there. Let's talk about a tumbling window via a tweet. If you wanted something that, say, counted the number of tweets every 10 seconds, well, this is what this might look like. So here's time, and these represent tweets. And if I'm doing creating a 10-second tumbling window, I'm basically just going, well, take 10 seconds and count the number of tweets, put that into my window, that's my answer. Move forward another 10 seconds, repeat the window, count how many tweets you see. Move forward another 10 seconds, that's my window, count the number of tweets. A basic tumbling window. Then you can hop in. So it's like the tumbling window, except it hops forward. Number of tweets in the past 10 seconds, repeated every 5 seconds. So for the same tweet stream, one for the first 10 seconds, there's my window. But now, 5 seconds later, i.e. here, it generates another window, looks back and sees how many tweets are in that window. So you can get a kind of a double count going on here because tweet 4, 6, and 2 are in this window and in this window. Now it moves forward another 5 seconds, looks back 10 seconds, gets another window generated. Moves forward another 5 seconds, looks back 10, another window, etc. So it's like steps going down in terms of what is its analysis period that it's looking at. Sliding. Count the number of tweets that occurred in the past 10 seconds from when a tweet arrives or is past 10 seconds. There's a lot going on in this one. Count the number of tweets that occurred in past 10 seconds from when a tweet arrives or is passed. So nothing happens, but on 10 seconds, a tweet happens. So a 10-second window is created. And then a couple of seconds later, another tweet happens. So another 10-second window is created. And then a little bit later, and 2 more tweets arrive, another 10-second window. Well, what happens here? Because there's no new tweet generated. There's nothing up here. But what has happened is my original tweet has now fallen out of the window, which in itself generates a new window. And we get the same repeat up here at around 23 seconds. Another window is generated because these tweets have fallen outside of the window. Up here, a tweet is generated, so it generates a window. And then 10 seconds later, no more tweets. So that's the last tweet. It's fallen out of the window. So one more window is generated. That's a very verbose one. Generates a lot of information when you look at it that way. There's what we call a session window. And for some reason here in Microsoft Docs, they change from seconds to minutes. So I'm running with it. Count the number of tweets that happened within 5 minutes of each other over a 10-minute period from the first tweet. On a tweet timeline, this looks like this. A tweet is generated, it generates a window. Within 5 minutes of each other, within 5 minutes, another tweet is generated, so it generates the window. And then 5 minutes later, it closes off that window. Then there's no window going on here because nothing's happened. But then at around 12 minutes, another tweet is generated, opens up a window, Another tweet is generated, keeps the window open. Another tweet is generated, so it keeps the window open. And the window grows and grows and grows until eventually a 5-minute period passes when there's no more tweets and it closes off the window. And then we get another repeat of it up here. So more of a kind of clustering way of looking at your data, kind of puts it into clusters of information. And then there's one more snapshot, which is a number of tweets that happen at the same time. So in this case in here, if all of these tweets are generated at 5 seconds, it will go, right, that's one window, and that's another window, and that's another window here, and that's another window there. Okay? So there's my 5 types of windows. So I'm going to go in and I'm going to do a little bit of demo about how they kind of work with each other, all right? Let's pop back into Azure. I should have done this earlier. I'm going to stop my streaming job, and it takes about a minute to stop, so hence I should have done that earlier. So apologies for the small delay here. But while we're doing this, let's just talk a little bit more about the outputs. Still can't show you because this job is still running. I'm going to just pop back while we're waiting and show you a little bit about the event hub, because I kind of skip over the event hub. We take it for granted. But actually, the event hub is a very simple, straightforward object. Service you spin up. There's a few different flavors of it. But once you set it up, you set up you can have a different sort of partitioning strategy going on behind all of them in there. But really, it's just a service. It's just a URL. It's just something that you can go to. There's kind of not much more in it. Sorry, my job is finished. My stream analytics is finished. Just pop back into here. Right. Okay, before I get into showing you the windows, I'm just going to show you the output. So let's go create an output. Now I can see in here. So now that my job is stopped, I can see various different output sources. So I can always connect to my event hub is my primary place a stream analytics job gets its data from. But once it's done its analysis, it can push it into various different places, including other event hubs if you needed it, but SQL database in my case. Okay. Now, my stream is still running, by the way. Okay, I'm still sending my data. My event hub is still receiving, but I've turned off my stream analytics job. That's not a problem. It will just hold it in the event hub, because that's what the event hub does. It holds messages until they're taken. So it will now just hold them, queue them up. I can turn off my stream analytics job, do some work. And when I turn it back on, I have the option of going back in time to start it from when I last stopped. So I'm going to go in looking at my query. Okay, and with my query, I can go into test query. But what I want to do is I actually want to test it on sample data. We see down here, it actually gives me a kind of a preview of the data it's been capturing all the time. And obviously that's very useful to kind of understand what's coming in. But for the purposes of this, I'm going to upload a set of data to it. And oops, I just remembered I moved where this is. Streaming data capture. Here's my test data. Okay. So here's my test data that I've loaded up from a text file. Okay. And I just want to talk through it. I'm pretending to be a MAC address in here. And down here, an event has happened. And you can see this happened at 41 seconds past 8:40. And then it happens again at 46, another event at 49, and then another event at 55. And then a minute later, I have another event. And then a little bit earlier, but a different MAC address, I had an event. And 2 seconds later, I had another event. So if I was to look at that, if I was to try to analyze that data, I would probably kind of go, well, these 4 in here all happen around about the same time. So I probably would view them as a particular type of visitor. And then this guy isn't a visitor to the shop because I've only seen him once, so I'm not really interested in that. And then this one is kind of an orphan on his own. So let's look. It looked like when I run it. So I'm going to run this first one. Sorry, not this first one. First one is just a straight copy. So that's not particularly interesting. That just reads my data. Go down into here. Let's do this. This is my tumbling window. Okay, let's run that, test it. And here's the results it puts out. So remember, the tumbling window was basically 10-second windows. Okay, 10-second window, next 10 seconds, then next 10 seconds. So it's looked at its source data. It's created a window shape in here. So you can see the first one was generated at 50 seconds and 10 seconds later, then 10 seconds later, and then a little bit later again, all right? And it's just done a straight count, okay? So it's counted how many people it saw in that 10-second window, and sure enough, MAC address 1.1 was seen, classified as a visitor because it saw more than twice. But this one, 1.1 again, which was just outside a 10-second window, has been classified separately as a passerby. So it didn't see it in the window, so it disregards it, okay, and counts it in a separate window. So this isn't bad, but I probably would prefer to see this guy classified as a visitor as well, because from a clustering point of view, it looks like it's so close to this window, I think it should be considered. So that's what that one does. Go on and look at the next one. Hopping window. Now the hopping window, remember, this is every 10 seconds, repeat every 5 seconds. But let's go run that. And if you've been keeping track of COVID statistics, I don't know over in America, but over in Ireland, at least nightly, there was a kind of case of what they called it, the incident rate in the past 14 days. That's a hopping window, because every night they told us what the past 14 days was. So we were looking back 14 days every night. So this is what my hopping window is. And now I'm getting more rows produced out of it. Okay, so if I'm looking at in here, the first window is generated 45 seconds, then at 50, then 55 seconds, then a minute. So it's doing its repeating every 5 seconds. And then looking back in time, sees it first as a passerby, then it moves on, suddenly classifies them as a visitor, then it repeats as another visitor, then drops the passerby and is passerby and all the rest of them. So there's more information coming out of here than I probably want in this circumstance because of that whole 10 seconds every 5 seconds rule. Let's move on to the next one, which is a sliding window. Sliding window is a very busy window. It's when data moves in and out of a window. So when you go looking at this, you're going to get more rows of data out than in. Okay, on the in we had 1, 2, 3, 4, we had 7 rows of data, but on the out I'm getting, I don't know, a dozen rows of data. Okay, and this is because things are moving in and out of the window the whole time. So when the first event happened, it generates a window. But then the second event happened and it generated another window. A third event happened, generated another window again. But it's all for the same MAC address. And then it moves forward, it drops it back. Now what's happening is actually an old event has dropped off and a new one has come in, so it's a new window. And you can see the kind of history in here. It's like he's gone from passerby to visitor, then he's dropped the passerby, now he's a visitor again, and now he's dropped off the passerby. I liken it to, it's like if there's a person at your shop door shouting at you about what's going on. So saying, oh, here comes a person. The person's in the shop. The person's still in the shop. Oh, I can't see the person. Person's in the shop again. Person's leaving the shop. A very, very kind of shouty way of looking at your data. So let's a bit more. Session window. The session window was when an event happens, expand the window until nothing else happens. But if it repeats, keep expanding the window. Let's run that one. And in this case, I'm going to get 3 rows of generated output onto it. And what's happening here is the first 4 times this visitor is seen have all been classified as one visitor, even though they occurred over in longer than a 10-second period from the first and the last occurrence was greater than 10 seconds. But that's okay because it grows the window until the timeout exceeds. So going back to my preview data, it saw them here, continue to see them. Then this was a minute later, by which time it had exceeded how long the window should stay open for, and so it closed off the window. So this is a nice way of kind of clustering up those 4 rows of data together inside in here. And in this case, this is the algorithm I would go with, all right, because that's kind of what I wanted to happen in here. But just to show you the last hopping window, last sliding window rather, temporal window, this one. And this is snapshot based. So the minute something happens, it generates a window. So actually what's going to happen in here is it just outputs what it saw on the input, because everything happened independently in here. I had nothing happen. I didn't have any 2 events happen at the same time. So there's basically 7 inputs and 7 outputs produced. They're all, of course, considered passerby now, because in each one of those little windows, there's only sight of 1. So the snapshot's a little bit different. What it's going for, it's more just capturing an event. Great. I am going to get on to a kind of question session. I just want to kind of move forward a little bit with this, guys. Okay, so I'm going to bring us back to this. Okay, bring us back to this one, because this was the query that I thought was going to work for us. Again, just looking at the preview and saying, yeah, that's what I want. So we'll go back into here. I have no actual change to make in here. So at this point, I could turn on my event hub again. Just a little bit of noise going on in some places there, guys. I'm kind of muting people as I hear it, but you might just keep an eye on your mics and stuff. So now I'm going to kick off this job again. So, and this is where you get the option. So remember, my events have been coming in continuously. There they are. If I was to run a query now, it won't have changed in all the time that I've been speaking. All right, it's sitting at 964,000 in there now. That's what's going on in there. If I was to run that in around 20 seconds time, it won't have increased anything because the stream analytics job is not running, but the event hub is receiving all the time. I have an option. I want to go restarting this job. I can restart it from now, from a custom, or from when last stopped. So I can basically play catch up and go, okay, start that from when it last stopped, and that's going to crank up my job again. So we'll come back to that shortly. Let's pop onto PowerPoint. All right, so that's my tumbling windows. Let's talk a little bit about cost. The database, lots of options around databases. Event hubs, basically 2 flavors of it. You got a basic, which is €9 a month, and standard, which is €18 a month. All right, per TU, throughput unit is what a TU means. Okay, I'm going to talk a little bit about what a throughput unit is shortly. They also have a dedicated option, which will cost you close to €5,000 a month. There's also a charge on the ingress event. Okay, 2 cents per million events. Okay, the analytics job, we've got 2 types of way of working. We've got standard analytics and dedicated analytics. Dedicated analytics job is minimum 36 SUs, which is a streaming unit, another unit of measure. Streaming unit costs from 10 cents per hour, which works out around €75 a month. Okay, have up to 192 streaming units. If you had a stream analytics job that was consuming 192 streaming units, it would cost you approximately $15,000 a month to run. Well, let's talk about performance. Again, three areas I could scale: Event Hub, Stream Analytics, and Azure Database. I'm not going to talk about the Azure Database. Basically, an Event Hub starts with a namespace. And this is where you define whether you're basic or standard. Okay? And a basic or standard comes with certain limits, consumer groups, and a number of broker connections you can have. Whereas when you go to standard, you got more consumer groups and more broker connections. Basically, consumer group is downstream receiver of the data, okay? And broker connections are just sending data into that event hub. So depending on which one you need, you can go basic or standard. Change this. So in my situation, I've got this setting up in basic. You can then set the number of partitions, which actually helps the parallelism that you can pass into downstream systems. Change that one, so you have to do kind of an estimation to the correct one at the start. And then the key number is throughput units. Okay, 1 to 20 throughput units. throughput unit is 1 megabyte per second or 1,000 events a second, whichever is smaller. Okay. You can change this manually, or you could set this to auto-inflate to a limit as well. So thinking about that, if you were designing a system and you need an event hub to receive messages, you're basically asking the question of how many megs a second are coming in here, or how many messages a second are coming in. And if you're going to go and say, I'm going to receive 500 messages a second, and they're all just little bits and bytes, then you're going to handle that in 1 TU, all right? But if you got a system going on where, say, I don't know, there's really large data sets being thrown in at you, and it's coming from thousands and thousands of different things, and they're happening every second, you may have to have 10 TUs, you may even have to 20 TUs there to receive all of that. The stream analytics side. Just doing a bit of muting there. Stream analytics. So stream analytics all comes down to what they call a streaming unit. Okay, you can go from 1 to 192. It's a unit of CPU and memory. Each SU can roughly process 1 megabyte a second. So if you can remember the TU was roughly 1 megabyte a second, and the SU is roughly 1 megabyte a second, but you can have 192 SUs and only 20 TUs. So why have I got 192 SUs? Because it depends upon the efficiency of a lot of stuff. It depends upon the efficiency of your windowing functions, what type of windowing functions you have, how long they're capturing the data for, whether they're for seconds or minutes or hours. It depends on the cardinality of the data within that window, within the data set. Depends on your complexity of any query joins, depending on the data set, depending on the message coming in, you may have to do a lot of work to deconstruct the message. It depends on how many partitions are actually upstream of you. It depends on whether you're using any functions, and I'll have a look at the functions shortly. But as part of the stream analytics job, you can actually declare a function in your stream analytics job, which can call out to another part of the Azure ecosystem, but that function in itself raises an overhead on it. You're using reference data, which is another thing you can bring into a stream analytics job. Basically, the more complex the query is, the more SUs you might need to put behind it, which is why you got a lot more SU potential than TU potential. From a demo architecture, this is my demo architecture. That's approximately sending in 100,000 events a day. Okay, so if I was to analyze that and saying, well, look, that's 60 events a minute, 1 event a second. Clearly, I can handle that in 1 TU because it can handle 1,000 events a second. The stream analytics job, also, I'm not going to have any issues running that on a single SU, and you'll run this for €9 a month plus €75 a month Azure storage. So basically, you can have a basic streaming situation set up for less than $100 a month going on. Let's demo a little bit about all of those different bits and pieces we saw in there. Okay, find these. I've started up my job now. My streaming job, but actually from a scale point of view, this is where my streaming units would have been defined. Okay, and it's running at the moment, so I can't dynamically change it. However, it's not a problem. I can turn off my streaming job, change it, and turn on again, and pick up data from when I last stopped it. Okay, from my event hub side of things, I can go into my event hub, and up in here, and I've got a throughput units count, and at the moment this is actually running at 5 units a minute, or sorry, 5 units, and this is one I can auto scale, so I can send this backwards if I want. So I'm actually going to try to choke my system, and I'm going to pull that back, and that will do an update on my throughput unit, and once that's kicked in, we'll actually should see a drop in that's been dropping there. We'll actually should see probably a drop in my throughput performance shortly enough whenever that graph starts updating, because it won't be able to take in the volume of data that I'm sending to it. Okay, there are 2 places that you set it up. From a monitoring point of view, you're always paying attention to these graphs down here and looking at my SU efficiency. Clearly, my single SU job is able to handle this data quite easily because it's sitting there at 25% resource utilization. So my single SU is well able to handle this volume going on there. I get the same sense on my event hub in that you'll kind of see a message of, well, this is the messages that are coming through. You may have to do a bit of analysis in there to kind of go, well, how much data am I actually pushing at it as well? And am I getting the same throughput as requests coming in. Okay, so because these two things are sitting on top of each other and kind of going, yeah, well, look, I'm managing this volume in there. Now, it takes a while to shut things down and start things up again. So I'm basically just going to show you some snapshots of utilization when you increase the load. So looking at my streaming units, this is a test where I started off with 10 messages using a straightforward copy operation. Okay, 10 concurrent virtual APs being sent into it. And I can see my streaming unit is sitting at less than 15%. In here, same volume of messages, but I put on a slide-in window function, 10 seconds to 20, and you can see how the change of the introduction of the window and function increased the utilization. Over here, this is I kept with a slide-in window, but I went from 10 seconds with a 20-second max to 5 minutes with a 10-minute max. And now I'm beginning to stress it a little bit more. And there's actually my 10-minute window growing up as it has to store that data, but still I'm sitting at 30% PI utilization. But you get an idea of every change that you make to what you're sending in to the streaming unit increases the utilization that you need on it. And then putting on an even bigger slide-in window again. So here are my first little bits of sliding windows. I can now kind of see how this is actually stretching up, and I top out here at around 80%. So you might at this point be kind of going, okay, I'm seeing 80% utilization when I'm running the same query, but with a much longer slide-in window. So if I put that out to hours, then I'm probably going to hit the 100% limit at that point. And then you'd have to turn around and kind of go, okay, I'm going to have to increase my streaming units in here. You can see in this one, it averaged out at 90% in there at the time. From a messaging point of view, you can see the same going on there. All right. So these are various little tests I've done with bursting of messages going through. Okay. And here something interesting happened. This is when I kind of started loading up data onto it and spikes up, but then flatlines at around the 40K. 40K messages. Why would it flatline around 40K? Well, it was a single streaming unit, which is roughly 1,000 events a second. Add on the size of the message coming in there. You can see how 60,000 would be about as much you could handle in 1 minute, and it's sitting around 40,000. When you start stressing that, starting with a single throughput unit and a single streaming unit with 20 concurrent connections, sending 200 messages with a slide-in window of 5 minutes with a 10-minute max. And basically from a streaming unit utilization, actually handling that, it's all sitting around 54%. But if I look here from an event hub, I'm captured. I'm capped at around that 40K because I'm on 1 TU. So it can only handle that level of event coming in there, which means that my SU isn't that particularly pushed. All right, so my TU isn't sending all the information it's getting, it's sending as much as it's allowed. So what happens, and if I was to look at my network activity, back in my source system, you can see there, that was my network output at the time, 134 bytes a second happening. So what happens when I increase that to 4 throughput units, but I leave my streaming unit on 1? Same level of stress going on. You can see now my streaming analytics job has now gone up to 95% utilization. Okay, so definitely, so no other changes other than we allowed the event hub to take more data and send more data. Now our streaming unit, now our stream analytics job is under more pressure. And if I look at it from a throughput event in there, I've also greatly increased the number of events coming into me. Over here on my network side, I've essentially doubled my network throughput because now my event hub can receive more data. So I increase this then to 4 TUs and give myself 3 SUs on it. Same volume of messages going through, but now as opposed to a flat line on my streaming analytics, I'm now more getting back to that pattern that we saw before, which is increases with the window, close the window, starts a new window, close off the window, starts a new window. So, and going up to around a max of 85%. So within capacity now on the 3 SUs. So now I'm able to handle my volume of incoming messages, which also has increased, by the way, because now my streaming analytics can fully capture, can keep up with my event hub, and a slight more increase in your network traffic in there as well. So the main call out with all of those slides is the two work in tandem. Okay, if you have one TU, it has a certain capacity, so the downstream capacity is restricted by the upstream capacity. The upstream capacity is limiting the output, then the downstream capacity doesn't need that much. It only needs enough to handle what's given from the event hub. The minute I increase the event hub capacity, now you're going to have a corresponding stress potentially on the streaming unit, on the stream analytics job, and you might have to increase its capacity. As you increase its capacity, it could even maybe handle more from here, and they balance out. And really, it's just a case of playing around. You can do the maths to kind of work out what you think you have, and then you set up the demo, you set up the architecture, and you study the monitoring until you're happy with the utilizations you get out of it. So there's an interesting blog up up in Azure, which is a reference architecture for 1 billion events a day. That's the link to it. So if you do the maths behind that, 1 billion events a day equates to 700,000 events a minute, 12,000 events a second, and then you'll probably allow for a multiply of 1.5 when things get a little bit busier. So if you're reading at that, you'd say, I probably need to be able to handle 18,000 events a second. One TU can handle 1,000 events a second. So you will need 18 TUs, throughput units, for 18,000 events. Do the maths on the other side, which is, well, how many megs have I got? And let's assume every message is 250 bytes. So 18,000 events will be 4.5 megabytes a second coming in. A TU can handle approximately 1 megabyte a second. So therefore 18 certainly is over capacity for the megabyte size, but within capacity for the number of events. So an SU, streaming unit, is 1 megabyte a second. So looking at purely from the megabytes point of view, you're kind of going, well, I'm going to need at least 5 SUs to start consuming that 4 megs of data coming in there. But bearing in mind, you're going to allow for your query type and scale, etc. So in this case, you would probably start with 6. So you would set up an architecture with 18 throughput units and 6 streaming units, and then monitor to see how you're going to cope with that. Also from a partitioning point of view, each SU should have 2 partitions, actually, that should be easily. So that's what that architecture would look like. Or 18 event hubs, sorry, 1 event hub with 18 throughput units, or 1 stream analytics job, starting off with 6 SUs and putting it into whatever flavor database you're going to be putting it in there, which will cost, in terms of dollars, $422 plus $525, so roughly $1,000 a month to run an architecture that would be able to handle 1 billion events a day. So, summary and conclusion. Certainly quite quickly build a solution that can handle 1 billion events a day and more. Quick to build. The only real development around this is that stream analytics SQL query that you have to write. Easy to scale and easy to cost. If you need to add on TUs, you know how much you're going to pay for it. If you need to add on SUs, you know how much you're going to pay for it. So if a person turns around and gives you an ask, which suddenly says, I'm going to need more SUs to consume that, you can basically turn around and kind of go, well, you're going to have to pay for the SUs, and this is how much they cost. Again, 1 to 20, 192, and then Azure data. And that's as much as I'm going to show you in here, guys. I have a few minutes left, so I'd happily take any. Hop back in here just to verify that everything's back up and running now. And you can see there, yeah, I'm up to 1.2 million rows of data inside that. So, back up. So guys, if you have any questions, I think we're doing this one by your popping off mute if you just want to ask anything. I see a couple of hands raised. I saw Ed raised. You might have to turn off mute to get on to me, guys, if you want to ask anything. Unfortunately, I don't have chat, so...
Can you hear me? This is Itzhak.
Oh, hello.
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 First, thank you for the presentation.
No problem.
First of all, is an easy question. How do you create a spotlight effect with your mouse? It's very impressive. Especially on a big screen with lots of spots of data you don't know where to look at.
I love that question. That's a really easy question. Can you see this then? I'm holding up this thing here.
Yes, some kind of piece of plastic.
Yeah, it's what this is a Logitech Spotlight. You've had the name in your head. It's a Logitech Spotlight. It's a device. There's a USB side on the other side. You plug the USB into your computer. You hold this in your hand. You press the button, and my dot appears. And it's actually really, really useful. Highly recommend them. They're not the cheapest. They're about $100, I think. Okay, but there's probably other variations of it. But yeah, Logitech Spotlight. I love it. Good question. A nice, easy question.
Yeah, absolutely. You know, there is right now Windows 11 presentation by Microsoft. That's why probably the most of the folks are swayed that way. Yeah, it's in the US. Started at 11 a.m.
Oh yeah, I'm sure. Don't worry. We're not competition to each other. Any other questions in there, guys?
I have more questions, kind of real questions.
Yeah.
Is it possible, if you will clarify, what exactly an event for your demos? Because my understanding, event was arrival of some kind of message or file, and after that also you saved some file like CSV, and it was a few entries there. So what exactly constitutes an event?
You're spot on with your first comment, what you said in there. An event is a message. Okay, that's it. The events that I'm generating for this demo are here. All right. Sorry, I'll have to share off my screen brief. Oh no, my screen is still sharing, isn't it?
Yeah, we see a black background and something is coming, but what is it exactly?
The event in this case is just a JSON. It's a JSON file. That's it. It's a bit of JSON. It is, if I can have a look at it, how it's being generated in here. Oops, I hit an error, so I'm going to actually stop that. If I actually look at my C# code in here, all right, and I write horrible C# code, all right, but you can basically see the basic formation of it there, right? I'm just basically actually defining a little bit of JSON, okay? There's the opening curly brace. Then I'm defining something called AP, and I'm putting something onto it. I'm defining something called a MAC, defining something called a scene event. So I'm just creating a little JSON message, all right? And then inside in C# world, I'm firing that at an event hub, and my event hub connection is, where is it? Connection string, I guess. Sorry, I'm a terrible. I'm a cut and paste C# coder as opposed to a real coder, right? Oh, there it is. So there's my connection string. So this is the event hub endpoint that I'm getting to. So it's a service that you have, all right? And that's my connection to it. So that's Sycamore demo, service bus, windows.net. There's my shared access key, etc., etc. That's the name of the event hub that I'm pointing it to. All this down here is this is just a little bit of code that's running a loop that's just generating a JSON file, and then it's firing it at that hub. So the event is just a message. What I showed you in terms of the CSV file, that was just me loading up sample data. Okay, it's a nice thing you can do inside in the Stream Analytics job, where you can you've got two options in there. You can turn around and go, right, I'm doing some Stream Analytics work. So you can go to your Stream Analytics job. All right. You can go into edit query. All right, I'll have to do the stop again. Well, when that's stopped, you can go into edit query, and it gives you the options here. All right, where you can kind of go, okay, I can upload a sample file. So I chose to upload a sample file, but actually it's showing you here, this is the data it's been receiving. So these are all the events. Each one of these individual line was a single event being thrown at me. And if I want to turn around, I can view that into my JSON world, and it will turn around, connect to my event hub. You can see there how it's fetching events and just pull back the next set of events in there. So an event is just a message, and all the event hub is a service that just takes messages. The interesting thing about the event hub, though, is it takes messages and holds them. all right, and does nothing until they're requested, and then it passes them on to the downstream consumer. You do have an option on the standard Event Hub that you can actually receive a message and auto write it down onto blob storage. Okay, and I do know some people who are actually receiving messages that way. They're just saying, just send it to the Event Hub, and then they're using the Event Hub standard functionality to write it down onto blob storage, and then they go processing it inside in Synapse Analytics or something like that, which is another way of working in there as well.
I see.
All right.
Would it be? Yeah, thank you. Would it be possible to receive event as an XML file or files plural, and process them using the API down the stream?
So the Event Hub itself, I think XML is one of the formats in there. I'm just gonna have to check that now and there, because the Event Hub received a message. I think it's more it's more the fact that when you're taking it out, it's receiving it as a JSON. I'm sending a JSON into it. I believe you can, but I'm actually gonna have to double check that one, because I've only ever used it in just sending in a JSON file onto it. So let me check. Let me check on that one, and I can put up a comment on Twitter later on or something.
Thank you. This is my real scenario. I'm getting XML files as an event, and after that I need to pick up some pieces out of it, store them in the database in the regular columns, as well as XML data type.
Yeah. So but they're coming in all the time to you. Yeah, you're receiving them like a stream. Yeah, because I mean, obviously XML we can handle in different ways as well. All right.
Yes, not with kind of much of the volume, maybe like 10 of them a minute, but
yeah,
they're coming and coming and coming.
Yeah, they're well. So I mean, certainly from 2 seconds. Let me just do a check on that one. No.
You know what? We can do it. You can do it later. This is not important because I don't want to hijack the session. And I see the Ed Pearson also raise his hand.
Yeah, I wanted to ask Mark if you, going back to where you were talking about all the different windows.
Yes.
Are those, and you had in your query, it said like timestamp by a certain field, I think scene or something like that.
Yeah.
Is that what determines the window that you're talking about? For each one?
Yeah, so the so in my text file, I was simulating a timestamp, all right? But yes, that is the timestamp that it's been sent to you. So the tumbling windows will work around those. Okay, so when we're saying 10 seconds or 5 hours or a day, whatever it is, that is the scene event that is going on there. And it works around that. So there's going to be an implied timestamp happening in there. Okay.
So it's the window is based on the timestamp in the data, not when the Event Hub got it, right? Is that my understanding?
No, I'm just thinking of that one now and there, right? So I'm sending in stuff. Where am I generating my timestamp from? Let me check that. You're asking way tough questions.
The system timestamp.
I'm generating the timestamp in here. Yeah, so I'm generating it now from what I'm sent. So I'm deliberately doing my analysis on that scene in there. I'm actually choosing, in this case, I'm running a tumbling window over that.
Okay, but there could be some latency right between the timestamp your system is creating and when the Event Hub gets it. So I was asking, it's based on the time you're supplying it, not the time of the Event Hub receipt.
In my analysis, yeah, I'm doing it on the time that's seen in there. But you know what I'd love you to do? I'd love you to send me an email on that one, because I actually want to check into that one. All right, because I've got a little blank on it because it's been a while since I've been in here. And I'd like to check up on that to see on what are the other ways you can handle that, all right? So I think my contact details are in there. If you could actually reach out to me in that one, I'll do a check into it.
Okay. And you'll share this deck that you used as well?
Yeah, absolutely. I'll work that out with Gene afterwards.
Okay, thank you.
Awesome. Any more questions, guys? I'm conscious there that I think we're coming up to the top of the hour.
Mark,
so I don't know.
I have a really short one about partitioning. When you say partitioning, are you partitioning the output data or are you partitioning the the data at the query
Parents
level.
and the demo.
So inside the partition is an event hub concept happening in there. Okay. So you're setting up. Sorry, this is when I'm setting up the partitions inside here. You can have various different level partitions, and it is just standard partitioning in terms of it's allocating this. It's to do with your throughput of downstream systems. Okay, so you can actually have multiple stream analytics job consuming off your one event hub in here. All right.
Okay.
There is a watch in there that if you need to guarantee an efficient analysis of, say, not of the time, but say of a feature coming in, all right, then you might want to make sure that all of those are directed to a specific partition if the specific sequence of them arriving is important outside of the timing. But it's a pure event hub concept in terms of just efficiency of how it's storing data and then how it's received down below, or how it's received downstream. It's nothing to do with the stream analytics job in itself.
Oh, okay, got you. So when I query the data, I'm querying anything that came into the event hub. I don't care about the partitioning inside.
Yeah.
Gotcha.
Yeah.
Okay, understood.
Okay. Anything else, guys?
So far, so good.
No? Cool. I think we're top of the hour there, Gene, so we're probably finishing up here, I'd say, are we?
Yeah, I think we are done.
Cool.
Mark, would you please email me all your the link and the slide deck, and I will share it across with members and
Absolutely.
attendees.
No problem. Perfect. That's great. I'll do that, Gene. And guys, thanks very much for listening to me. And hopefully you found some use in there. And as I said, there's definitely a couple of questions that I got to check back in there with a little blank in it. So I will revert back to those in terms of that.
For some reason, there's a latency from my end. Can you hear me, Mark?
Yeah, I could hear you fine.
Mark, can you?
Yeah, I can hear you.
Hello?
Yeah, I'm here.
Can you guys hear?
I can hear anyway. I can hear you.
Same here. I can hear you well.
Yeah. I think it's on Gene's side.
Yeah, it looks like.
Perfect. Look, I'm going to rock off, guys. It was great chatting to you, okay?
Thank you very much.
Cheers, Sloan. Take care. Bye.
Bye.